Everybody, it's Mr. Ziegler again. In this video, we're going to be talking about partitioning a line segment. Now, there's some big words in there. Partitioning, what does that really mean? Well, basically what it is we have a line segment that we're dividing into uneven parts, okay? And so what you're going to have to do here is you're going to have to find the value on a number line that partitions a segment into uneven parts, okay? And we're going to be given some ratios of those two parts of the line segment, okay? And just to show you a couple of examples of how this works. Let's say that we have a line segment and we have a point on that line segment that divides this larger line segment into a 2-to-1 ratio. What does that mean? Well, that basically means that when we have this 2-to-1 ratio, the first part that's now being created, that smaller line segment on the left, here is twice as long as the one that's being created on the right. Therefore, the 2-to-1 ratio, 2 times as long as the one on the right. If we have a 1-to-3 ratio, for instance, that means that we've got a point here that's dividing this line segment into 2 smaller line segments, but now the one on the right is 3 times as long as the one on the left. Okay, and so you can have all kinds of different ratios. It doesn't have to be, you know, even like this where it's an even number value more than the other. You know, you could have a 3-to-2 ratio, you could have a 2-to-3 ratio, and we're going to be talking about what that really means. But essentially, you can kind of put those numbers together, like 3/2. That would be the same as a 3-to-2 ratio. Simplifies to 1.5 or 1.5. So this 3-to-2 ratio in this case would mean that the one on the left, now that new line segment, is about 1.5 times as long as the one on the right. Okay. But what you're going to have to do here, and we're going to use this example of this 3-to-2 ratio. What you're going to have to do is you're going to have to imagine that these line segments are on a number line. Okay. And we're going to try to have to figure out the value of the point that is partitioning this line segment into the 3-to-2 ratio. Okay, so for instance, let's say that this is part of a number line. Okay, and we have a line segment that extends from 2 to 12 on the number line, and now we've got this other point that's somewhere in between, and we want to know the value of that point that would divide this long line segment from 2 to 12 into a 3-to-2 ratio, where that left hand, the smaller line segment now that's been created from 2 to our mystery number now is a little bit bigger than the part on the right. Okay, and so there's a formula for this, but before we get into the formula though, I want to kind of show you how this works logically. Okay, so think about in that word partitioning. Okay, the first part of that word is part. And so I want you to think about when you see these ratios, well, those are parts, okay? And so if we can, basically what's happening is that we're splitting these into equal parts, okay? And so if we look at this 3-to-2 ratio, that means that there are 5 equal parts here. There's 3 of those parts that are on the left side now, and there's 2 of those parts that have been split off on the right-hand side. But total, if we looked at it all, we've got even parts here where we split it up, where 3 of those parts are going to be given to the left side, and 2 of those parts are going to be given to the line segment on the right side. Okay, and so if we can figure out how much each part is, then, you know, how many units each part is worth, then we can just kind of count over from our beginning end point over here on the left, and then we can just count our way up to that point that we're looking for. Okay, or we can do it vice versa. So what we need to do first then to figure out how much each part is worth, we need to know how long our total line segment is now, our big line segment, which extends from 2 to 12. In order to figure that out, all we have to do is subtract those two numbers. Okay, 12 minus 2 is 10, so that's this line segment here is 10 units long. And so if I divide that by the number of equal parts that I know exist here, remember we got a 3-to-2 ratio, we add those two numbers together, there's 5 equal parts. So if we take the 10 units and divide those by the 5 equal parts, then each part has to represent 2 units on our number line. And so all we have to do then is we're going to give 3 parts, which are all 2 units apiece, to the left-hand side, and then just count over by 2s until we get to the middle. So if we count by 2s 3 times, that'll get us to this point 8. Okay, so 8 should be the point that partitions this line segment into a 3:2 ratio. Now we can also count backwards from 12 if you wanted to. Remember, each part is going to be 2, and since we have 2 parts that represent the distance on the right between those 2 points now, we can subtract 2 a couple of times for those 2 parts, and that would also get us to 8. 12 minus the 4 then would get us to 8. Now, as I mentioned, there is a formula, okay? So whenever you have a ratio like this given to you, this B to A, and we're using letters, I know sometimes that's a little confusing, but these are going to represent 2 numbers in our ratio. One number compared to the other number, okay? And if we know those 2 endpoint values, then we've got this formula here that we can use, okay? Where we're basically taking the second number in our ratio, that B to A ratio, and multiplying it by the first endpoint value, and then we're taking the first part of our ratio with the second endpoint value and multiplying those together, add that up, and then divide by the total number of parts that we have. Remember, the total number of parts is just our 2 numbers in our ratio added together, okay? And so if we use our previous example of that 3:2 ratio, and again our 2 to 12 line segment, then all we have to do is plug those numbers into that formula, and then we'll figure out what that actual point value is. We don't have to add anything else. This is going to actually give us our point value. So if we take that number 2 and multiply it by our first endpoint of 2, and we take our 3 in our ratio and multiply it by the second endpoint of 12, and then we add everything on the bottom, we're going to eventually get to the point where we're taking 40 dividing by 5, and 40 divided by 5, you can't see behind my picture here, is 8. So that number is going to be 8, just like we found when we did the logical thinking that we did a minute ago by counting over the number of parts. Okay. So if you don't have that formula, I would take a screenshot of this or write this down really quickly, pause the video, and you can use that formula to figure out any of these points that lie in between the 2 endpoints. Okay.